today we're looking at long division, and there's another method we're going to use called synthetic division, and this will all be useful in something called the remainder theorem and the factor theorem. So this is what section 5.5 is all about. First thing we're going to have to remind ourselves how to do is long divide, except it's not long divide with numbers, it's long divide with variables. Here's the key. You want to look at just this first term out here to decide x squared times what will give you the first term on the inside. X squared times what gives you x to the third. That's x. Now whatever number you put up on the top is the number that you're going to use as a distribution times everything that you see out in the front. Some people like to write this off to the side with their distribution. It'll be x times x squared minus x minus 2. That's what you need to do a distribution with. X times x squared is x to the third. That x to the third goes underneath the other x to the third. X times negative x is negative x squared. That will go underneath our other x squared term. And x times negative 2 is negative 2x. I'm going to put that in here, negative 2x, but do you notice that I don't have a plain x term underneath my divide symbol? You can assume that that's a 0. Now, like other long division, when you put your numbers under here, you subtract. And we're going to subtract going right up and down. X to the third minus x to the third, those are gone. They should disappear. If they didn't disappear, you probably picked the wrong thing to multiply by. 3x to the second minus minus would become a plus plus. 3x squared plus x squared is 4x squared. And then 0 minus minus would be a plus plus. 0 plus 2x is that, plus 2x. Now we're going to drop down the next number, negative 7, and then we're going to start over. And again, when you start over, you're only using the number in the front, and you're putting that into the front number down here. X squared times what gives you 4x squared? That would be plus 4. X squared times what gives us 4x squared? 4. And now I'm going to do another distribution using just my plus 4 times everything that I see out here. Now for this one, I'm just going to show my distribution this way with the green marks instead of writing it over here. 4 times x squared is 4x squared. 4 times negative x is negative 4x. And 4 times negative 2 is negative 8. And again, this is a subtraction. 4x squared minus 4x squared is gone. 2x minus minus is plus plus. 2x plus 4x is 6x. Negative 7 minus minus, there's another plus plus. Negative 7 plus 8 is 1. Now at this stage, when you end up with something underneath like this, 6x plus 1, when you end up with something underneath that's smaller degree than what you have out in the front, x squared, when your 6x to the first is smaller than this x to the second, then you're done. You can't go any farther. So this quantity down here that I circled is considered your remainder. What we've got as our answer then is the stuff that's up on the top, x plus 4, and then we've got this entire remainder, 6x plus 1. But remember, remainders have to look like a fraction. So it's 6x plus 1 over the entire divisor that's written out here, x squared minus x minus 2. And this entire thing will be our solution. All right, we got to try that one more time. Let's try this one. X plus 3 is being divided into 3x to the third plus 17x squared plus 21x minus 11. So if you think you can go ahead and get this one started, you can hit pause. If not, let's just follow along right here. X times what gives us 3x to the third? 3x squared. Now I'm going to do a distribution. 3x squared times x is 3x to the third. 3x squared times 3 is 9x squared. And I subtract. 3x to the third minus 3x to the third is gone. 17x squared minus 9x squared is 8x squared. And I'll drop down my next term, positive 21x. I'll use a new color. Start fresh. X times what gives you 8x to the second, positive 8x. Distribution time. 8x times what is, 8x times x is 8x squared. 8x times 3 is 24x. And remember to subtract. 8x squared minus 8x squared will disappear. 21x minus 24x, negative 3x. And I drop down my last term of negative 11. And we'll divide one more time. X times what gives you negative 3x, negative 3. And we do our last distribution. Negative 3 times x is negative 3x. Negative 3 times 3, negative 9. Do your subtraction. This will disappear. And then remember to go out to your minus sign. Negative 11 minus minus becomes plus plus. Negative 11 plus 9 is negative 2. Negative 2 will be our remainder. We've got 3x squared plus 8x minus 3. And the remainder of negative 2, write your remainder as a fraction, negative 2 over the quantity x plus 3. There you go, long division. Now, there is an easier way that we can divide, and this is called synthetic division. But the one thing you have to remember is that synthetic division only works if what you're dividing by is 1x minus k, and then k is your constant, could be any number. So if I look really quickly at this first example, I'm dividing by x plus 3. This is a 1x. That works. X plus 3. I cannot have a variable in the back. It has to be just a plain constant. So here's how we do our synthetic division. What you're going to take is just the constants in the fronts of every variable, and then you also use that last number sitting in the back. 3, 17, 21, negative 11. I write those numbers down. 3, 17, 21, negative 11. Another thing to look for, your x terms have to go in order, working their way down, and you have to use every single power. If I start with x to the third, the next one has to be x to the second, and then x to the first. If one of these x's is missing, for instance, if this x term weren't even here, this x squared term, I would have to put in a 0 as a holding place for that. So be very careful when you look at your questions. Are all of the x terms visible? If not, put in a 0 as a holding place. All right, so again, we've got 3, 17, 21, negative 11. I write those numbers down. Now what I want you to do on your paper is leave a blank space. Leave a blank space. Then you're going to put your divide box way underneath that blank space. And then we're going to be dividing by something. And here's what you're going to be using as your dividing by. Whatever the divisor is here, x plus 3, you need to take that out and solve it. And when you solve, you get x equals negative 3. It's that negative 3 number that will be going out here. So here's the process now with synthetic divide. First number always drops straight down and goes in the box. So drop the 3. Now what we're going to do is alternate back and forth with multiply and subtract, multiply and subtract. Well, what do I mean by that? Multiply. 3 times negative 3 is negative 9. That negative 9 is going to go right here underneath our 17. Now we add. Multiply, add, multiply, add. 17 subtract, or plus negative 9, or subtracting 9, is 8. Multiply. Negative 3 times 8 is negative 24. That negative 24 comes up here underneath my next number. And now I add again. 21 plus negative 24 is negative 3. And I go one more time with a multiply. Negative 3 times negative 3 is 9. And I add these two numbers, and I get a negative 2. No matter what happens, this number sitting in the back will always be our remainder. Sometimes you'll get a 0 right here, which means you have no remainder. Sometimes you do have a remainder. But now you have to decide, how do I write this answer each of these numbers that I've got here, 3, 8, and negative 3, are always the numbers in the front of my x's. So this 3 would be the number in the front of my first x term. Well, how do you know what x term it's going to be? You're always going to take 1 degree less than whatever the problem started with. 1 degree less. I started with x to the third. That means my answer is 1 degree less than x to the third, which is x to the second. And now I work my way down the line with each of the numbers. My next number is positive 8, and my next degree is x to the first. My next number is negative 3. I will not have an x term here. X to the second, x to the first, no x term. And remember, we've got this remainder, negative 2 over, and what was it that we originally divided by? We divided by x plus 3. So I put my x plus 3 right there. There's your question. 3x squared plus 8x minus 3 with the remainder of negative 2 over x plus 3. Now, if you notice, that was the exact same question we just did as a long divide. Same answer as synthetic division. Let's try one more of those. Synthetic divide. Only the numbers in the front is what we use. Are each of your x's visible? X to the third, x to the second, x to the first, and then your plain constant. Yes, they're all visible. I don't need a holding place. 2, 9, 14, 5. Leave one blank line under that. Draw your box under that. And out here, I have to decide what I'm going to divide by. My original question is x minus 3. When I solve that, I get x equals 3. Positive 3 is my number that will go out here. And now we'll start our process. Drop the 2. Multiply, I get 6. Add, I get 15. Multiply, I get 45. Add, I get 59. Multiply, what's 3 times 59? Good, 127. Grab your calculators if you need to. And then I add, and I get 182. Remember what this number is in the back? That's always the remainder. And now we can write the answer. 2x to the what? 1 degree less than what we started with. We started with x to the third. This is x to the second. And now I'll work my way down the line. Plus 15x to the first, plus 59, plus 182 as my remainder, which means 182 over x minus 3. And there's your synthetic division part. All right, so there's the end of your first half of this video of section 5.5 with long division and synthetic division. You might want to try a couple of those from your notes, and then remember you have to watch the second video that will go with this.